In this video, I'm going to talk about data-related operators and directives. There are non-executable statements. We can use them to get address info or size info. And I'm going to talk about offset, PTR, type, length of, size of a label. Okay. First one is offset operator. We can use offset operator to get address info. So offset returns the distance of a variable or you say data label from the beginning of your data segment. We have talked about the data segment. It's a storage location located for your assembly program. Each program will have a data segment that's part of memory space used for you to declare variables. So in your data segment, you have a beginning address. Each variable will have an offset to the beginning address. So this offset means the distance in bytes. Here we have example. There are 4 variables here: byte, word, double word. In the code segment, we're going to move the offset of each of these variables into the register ESI. So we can move b values offset, that means b values distance from the beginning of data segment to ESI. If we assuming the beginning address of this data segment is 00404,000H, this is his decimal address. So the first b values address will be their beginning address. So ESI after this statement will be this much. The second variable w value, if we bring the distance offset to ESI, the distance of ESI will be 00404,101 because the first variable use 1 byte, so the second variable's address will be beginning address plus 1 byte. In the third statement, we're going to bring the address of d value into ESI. Beginning address plus 1 byte plus 2 byte, that means plus 3 byte, you get a d value's beginning address. That is offset, so it's going to be 4003H. The last one's address or offset will be this plus 1 byte, 2 byte, 4 bytes, total 7 bytes. So the beginning address, the offset d value 2 will be this plus 7. So that's 404007H. So use offset operator, you can get the address of a variable or array elements. So related with C++ or C, we can compare their code. In C++, you can declare a char array with size 1000, and then you declare a char pointer, and you say your char pointer is going to equal array. This means the pointer P is holding this array's address. In assembly language, if we want to do something similar, we can say in the data segment we have array. The size is byte, and the data type is byte. The size is 1000. We initialize with nothing. If we want a pointer, so we can say move ESI with offset array. That means ESI is holding the same address as this array. So ESI here is working as a pointer kind. PTR operator is another important operator. It's going to override the default type of a variable, give us the flexibility to access partially of a variable. Here is the example. In the data segment, you have my double is a double word, and the initial value is 1, 2, 3, 4, 5, 6, 7, 8 each. So it's 8 digits. In the code segment, we're going to copy, move my double into AX. This statement is going to cause error. The reason is the size mismatch. AX 2 bytes, my double is 4 bytes. You cannot do this. Whenever you write a move statement, their size must match. However, we can use a PTR operator to override the my double's default size. What we do is we're going to say AX, move AX with word PTR. That means just move partially my double. That means you move partially a word from my double into AX. Partially, we want a word from my word. That's going to be 5, 6, 7, 8. This is the lowest. The first half. Okay. Let me undo. Sorry. Okay, so we have loaded the lower half into AX. Intel computer use little Endian order. So 5, 6, 7, 8 is the lowest half. It's going to be loaded into AX. Also, you can use PTR operator to bring a partially answer into a bigger size variable, like 4321H is a hexadecimal constant we can bring into my double. So this is a word, 2 bytes. You want to move into 4 bytes, you can tell the computer, you just fill up with partially my double. Word PTR my double means just fill up a word of my double using 4321H. Little Endian order. This is the Intel computer's order. It's going to tell us how the Intel computer stores their integers in memory. Suppose we are going to store this hexadecimal number. It's 8 hexadecimal digits. When it's stored and it's going to go by byte. This is 4 cells in the memory. The 7, 8 is the lowest byte. It's going to, the least significant byte is going to go to the low address. The significant bytes, the leftmost byte is the most significant byte, will go to the higher address. Offset means higher address. So this offset means the memory address in the RAM. So this is a little Endian order. Lowest byte go to lower address. Okay, continue with PTR operator examples. So you can think computer store 1, 2, 3, 4, 5, 6, 7, 8 H as a double word. Here like this. We declare my double is double word with this much. So you can treat the whole number as a double word as a whole thing in memory, or you can treat this whole number as 2 word. First word is 5, 6, 7, 8, is 2 bytes. Second word is 1, 2, 3, 4, the second 2 bytes. Or you can think the memory layout of this number as 1, 2, 3, 4, 5, 6, 7, 8, from the lowest byte to the highest byte. So this is a memory layout. You can think about how the computer store these big double word numbers. Let's see how to use PTR to access to partially of this variable. Suppose you just want the first byte, the least significant byte. You can say move AR with byte PTR my double. So after this statement, you're going to see AR equals 78H. You want to see the second, you want to get the copy the second byte, that means 56 in this number. You want to copy this byte out to a register, or you can say my double plus 1. This is the second byte address. You put a bracket around it. You have to use byte PTR. That means override the default 4 bytes. That means you just need partially this variable's number. So the third one is 34. So you have to get the third one's address. The third one's address, my double, that means beginning address plus 2 bytes. So you get the third one's address, that's 34. You put a dereference operator around, that means you copy the content. You copy 34 into AL. If you want to copy half of my double, that means you want to copy 5, 6, 7, 8. You can just say you want to move AX with a word in my double. Suppose you want to copy second word, that means 1, 2, 3, 4 into 1, 2, 3, 4 into AX. You have to say my double plus 2. That means the beginning address plus 2 bytes you get to the second word. Okay, let me show you in the Visual Studio. I have done my coding and I start my program. I have 2 messages like before. I have my double variable. I have variable 1 and the list 1. So for PTR operator, I'm going to use my double. So I put my double, the first word 78 into AL. I put the second byte, my double plus 1 into AH, that's 56. I put the third byte, that means 34 into BL, and I put the first word 5, 6, 7, 8 into AX. Also, I put a second word 1, 2, 3, 4 into SI register. Okay, let me run. I'm going to dump register to show you the values to verify. So let me build my solution. I'm going to execute my solution. In my execution, the first dump register is going to show me AR. AR is 78. The first 2 digits in UX is AR, so that's 78 is right. Second AH, that's the second 2 digits is 5, 6, so this is right. BR is 34, and this 2 numbers is BR, that's 34. And I use CX to get the first word should be 5, 6, 7, 8. So this ECX, half is CX. So this is half CX, that's 5, 6, 7, 8. This one is right. I put the second word 1, 2, 3, 4 into SI. So let me see. This is ESI. Half is SI. So half is the lowest half, that's 1, 2, 3, 4. So it's right. So I have verified the PTR operators. Continue with PowerPoints. I'm going to show you more operators. Okay. Your turn. You can try this out by yourself. The type operator is going to return the variable's size in bytes. If you have variable 1 as byte, and if you say move, that means copy type variable 1's size into UX. The type variable 1 is byte, that means, so UX is going to get 1. If you copy the type variable 2 into UX and is word, variable 2 is word, that's going to be 2 into UX. Type variable 3 is double word. Double word is 4 bytes, so 4 will get into UX. LENGTHOF is going to tell you the number of elements in an array. For example, in array 1, we have word as the size, as a storage type, and array size is 30, duplicate with nothing, and then you follow by 200. So the array size of array 1, it should be 32, because 30 plus 2 more here. If we want to get the size of array 1 when we do programming, we are going to write something similar to this. We can say move ECX with length of array 1. Length of is going to return the array size of array 1 and copy into ECX. Size of operator is going to return the storage size used by our array. Take array 1 as an example again. We know array 1 is a word, size 32. Size 32, but each one uses 2 bytes is a word. So the total storage bytes used by array 1 will be 30 times 2. So 32 times 2 is going to be 64. So if you do coding like this, your answer in ECX will be 64. So size of is going to calculate the bytes used by an array. So size of equals length of times type. You can declare your array crossing multiple lines. Make sure each line separated by comma except the last one. Okay, here let me show you a few more operators in my programming side. Okay, I have showing how to use the PTR. Here I'm going to show you how to use type of, length of, size of. So before I use them, I'm going to clean up EAX, ECX, EBX. I initialize them with zeros. Then I'm going to bring AR with type V1. Okay, let's see variable V1. V1 is a byte, so AR is going to get 1. AH is going to get type list. My list is word type, so the AH is going to get 2 because word has 2 bytes. I move length of list, that means the size of list into EBX. List size is 6. I have 6 decimal numbers here. So list length is 6. EBX will get 6. Finally, I calculate the size of list. This size will be 6 times 2. That should be 12. So ECS will get 12. Okay, let me show you one dump register I can verify in this register's location. So let me check my second dump register. I should have AR with 1. Yes, I have AR, this 2 digits, that's 1. I should have AH with 2, that's the second byte in UX, that's 0, 2 is right. I should have EBX with 6, so I use EBX, so that's 6. I should have ECX with 12. ECS is C. C is 12 in hexadecimal, so my answer is alright. Thank you for watching this video.